Hey everyone, and welcome back to another Niagara tutorial. Just a few quick things before we get started, just so you know what you'll need to follow along. For the engine version, this time I've updated everything to 4.26. I was trying to keep everything as kind of early in the build stages as possible, but it seems as though using 4.25, a lot of people were using the newer version and things just weren't working. So hopefully this won't break when they release 4.27, but at the moment this is going to be in 4.26. So that's definitely going to be the easiest way for you to follow along. Next, this is going to be a little bit of a longer one. We'll be making this laser effect in the background. This is going to be made up of two different parts. So we'll be making the beam and then the laser impact. We'll also be doing some blueprint work here. But a lot of people have been asking me to cover exposing parameters, doing things in the blueprints with the Niagara effects. So I'm going to try and do that in a very kind of simple way in this video, and if that's popular, then I'll try and do some more complex or intermediate kind of examples of working with exposed properties and affecting your Niagara particle effect through blueprints. So inside of the template project, which just to mention, if you wanted full access to the source here, have a look at the Patreon tiers. You can support the channel, the work that I do and everything to keep this going over on Patreon. And I do try to provide some extra goodies for that support. And one of those will be full access to any of the source content that I produce when creating these tutorials. So in this existing project, I'm just going to go to the effects folder and we'll start by creating the laser beam itself. So we're going to right click in here. We'll go down to our effects. And as always, we're going to start with an emitter and then we'll turn this into a Niagara system a little bit later so that we have that extra usability and kind of reusability, I suppose. We'll create this one from a new template, and I think the easiest one in this case is actually going to be empty, as none of these really start with what we want it to have. So we'll create an empty emitter and we'll call this one NE_laser. So the first thing that we're going to want to do is remove the sprite renderer. I'm just going to delete that and we'll create a new renderer down here, and we'll be using the ribbon renderer instead. Now all of these will default pretty much to what we want this to be. The one thing we will need just here is the material. So selecting the material dropdown, we're going to go to the view options, and this I think used to be under engine content. So if you are following along in an older or newer version, if they move this around and you can't find it, in 4.26, if we tick instead the show plugin content where it used to be engine content, we can see that we have the option for the default, or we should see that we'll have access to the default ribbon particle. Okay, so interesting thing here as I was changing to find out where this is. It actually seems to now be nested. So if we tick the show engine content, it's no longer there. If we have just the plugin content, we can see again it's not there. We need both of these ticked now, so this may have caught some people out, so I'll include this. We need the engine and the plugin content shown. We then have our default ribbon material, which is really all we want for our laser. And then in the view options, I'm just going to come back and untick both of those, as we won't need that again. For now at least, and that will keep things a little bit tidier. So let's just check the details as we go through now then. So for the emitter update settings, we're going to want the life cycle to be relevant to self rather than system. We don't necessarily want this looping, so we'll set this to infinite with a loop duration of 0, which means it won't have a kind of set number of loops to hit. And then the first thing we're going to want to add to the emitter update here is a beam emitter setup module. So if we click the add module, and we'll find that one. So we'll need this to work regardless. We will be coming back and editing this a little bit later. As we go through, this is going to give us some visual updates to just get the general idea of the design that we want as we go through. This is going to be one of those values that we turn into a parameter and affect through our blueprint though. So we want to make sure that we tick the beam end to be absolute. So we're just going to be controlling where it starts and where it ends. Then we're going to want another module here, which is the spawn burst instantaneous. So with this one, I'm just going to set this to have a spawn count of 2, and we can leave the spawn time set to 0. Then down below, we're going to move on to the particle spawn system. Adding a new module here, I'm going to go with the beam width. We're going to want to control how wide this is, and you'll see that this throws up an error just saying that this is based on using the spawn beam. So this way we can just create that one module, and this will automatically, if we allow that to fix the problem, it will create the spawn beam that we need as well. So we now have these two modules. We don't need to edit anything on the spawn beam. The spawn width is going to control obviously how wide our laser is. So if we update this, we can see we can change the size of this. I think in the tests I went for something like 15, so I'm going to use that again. And then if we hop back up to our emitter setup, this is where we can now see we can change how long this beam is. So we're saying that we want the absolute end to be 300 units away from the start point just here. Now ideally, again, this is where we're going to look at the blueprints, and we'll be changing this to be dynamically based on the end point of a line trace or something. So don't worry too much right now about what you set this to. We're going to change this to a custom parameter a little bit later. Then finally, the last two things down on the particle update. I'm just going to add a color module and an update beam module. So again, the color seems like another good thing that we can change to a parameter. So we can see another way that we can change a vector parameter and a float value here through blueprints. Just for demonstration, though, if you wanted to, you could come in and give this a new color so that we can see what this is going to look like if we do change the color of our laser as we go through. That is pretty much everything though. So that is, we're going to make a very simple laser. Like I said, the main thing is we're getting that kind of functionality, and exposing parameters is going to be the important thing here. So if we start with the color, what we want to do is come over to the left-hand side, and we can see we have these user exposed parameters. The first one, I'm going to create a new color parameter. So we want a linear color, and we'll just call this one color. Then in Niagara, to assign this to a variable, it is as difficult as coming over to the variable you want to replace. So rather than having this set in the Niagara system or the Niagara emitter, we're going to drop this down. We'll connect this to a user created value. So if we type in user, it will then give you a list of all of the things that we've created. So if we select our color variable, this will now link that to a parameter named color. So you'll see that that defaults back to white because we haven't set that to be anything here. Now that's fine because again, this is all going to be overridden and updated in the blueprints anyway. Next, I'll do the same thing for the end of the laser point. So this is actually going to now remove this visualization, which is why I wanted to get this set up first. But we'll create another user exposed variable. This one's going to be of type vector3, or just a vector as it's called here. And I'll name this one laser end. Then to set this one, we're going to go to the beam emitter setup. We want to replace the beam end with, rather than having this hard-coded 380 units, we'll drop down again, we'll go to our user options. And we can see here, the only one that it knows fits this requirement is our vector, which is our laser end, so we'll replace that there. Now again, this defaults to nothing or 0 on all of the points, so we'll see again that the laser disappears completely, but that is perfectly fine. We now have our base emitter, and we can create our system, and then we can use this in Blueprint. So if we compile and save that, we can go back to our main folder. As always, we're going to right click on our emitter here. We'll go to the Create Niagara System option, and I'm just going to rename this one to ns_laser. So a few things if you did want to start playing around with this. Now that we have our system, we can come into the ns_laser. This blue node which is provided here has the custom modules exposed. So we can now change the laser end. So again, we could start viewing this in our system, playing around with the colors again and everything, and getting those kind of live updates. That's not really required because the very next step is that we're going to be throwing this into a blueprint and controlling everything through our code. Before doing that, we'll just create our impact point as well so that we have both of our Niagara systems ready to go inside of our blueprint. I'll just save all of these changes and close the tabs here. We don't need any of those anymore. We're now going to create a new emitter, which is going to be a kind of burst of particles when a solid surface is detected. So I'm going to right click, go to our effects, and again, we'll make this an emitter to begin in case we want to reuse this. I'm going to go from an empty template, and this one, just so that we have something to go with, I suppose we could use the omnidirectional burst. It seems like the most relevant one to what we're going to be doing. And I'll call this one NE_laser impact. Okay, so the main thing is we have our sprite renderer set up. We're going to be using a sprite renderer here rather than a mesh, which is something I usually like to do, but this is going to be a nice, cheap and simple effect that we're going for. For the settings, I think all of this as default is going to be perfectly fine. The update values are pretty much as we want them. Setting the life cycle to self is perfect. We do want the loop behavior to be infinite. And again, we're going to set the loop duration to be 0 on this, so we don't want this to play any specific number of times. The spawn count here we can see is a little bit excessive. This is only going to be a kind of visual representation of hitting a wall. So as well as currently being a fountain, this is playing a little bit too many. We're going to turn the spawn count down from 100 to maybe something like 10. Then for the particle spawn is going to be the next thing we want to update. We have a few too many things here, so we don't need pretty much any of these, I think. All of this is going to be done on the update, so we can select the calculate, the sphere location, and the add here, and just delete those. We'll get rid of those completely. We only really want the initialization here. This is going to be a little bit harder to work with now that we've got rid of everything, but we will be adding some things into the update, and we'll come back here and change this in just a second. So for the update, we also don't want any gravity or anything being applied, so we can immediately get rid of our gravity and drag. We don't want the scale color here. We will just do a kind of flat color, and we do want the scale sprite size. Because we've removed the gravity-based things, we can get rid of the solve, forces, and velocity. And the two things that we need to add back in, we're going to add a flat color rather than a scaled color. Again, we'll be replacing this with a parameter a little bit later. And then we can also add in a sphere location just to kind of keep this clumped together. So the scale sprite size is possibly not quite what we're looking for at the moment. I'm going to start this at 0. So at 0 seconds, we're going to make this quite small. We'll have this kind of burst into existence fairly early on. I think I might make this quite big. And then I'll drag select all of these and do an auto curve on this. The sphere location is going to be quite simple. We're just going to make this a fairly small sphere that we'll be working with. It's, again, a very kind of compact point of the laser hitting something. So I'll turn this to a sphere size of 25. We can leave everything else as is, and then we're going to want to go back to our particle spawn. We don't need the lifetime to be quite this high, so we'll turn this down to 0.3 and a maximum of 0.8. And then for the sprite attributes, we're going to make this a random non-uniform. So this is where we can start seeing the, this is kind of what this is going to look like when it's hitting a surface. I don't really want any gaps in between this. I'm going to make these much bigger, kind of by default. So let's make this a minimum on the X and Y of 15 and a maximum of 30. So that kind of really nicely fills any gaps. And from a distance, this will look pretty much spherical and as though there's just a kind of impact right at the end of our laser. And that's really it. So like I said, this is going to be a very simple one. The main thing again is that we want to check how we can update this through blueprints with an exposed variable. So very similar to our other system, we'll create a user exposed color. And again, just name this one color. And quite simply, this is going to be the only thing I change here, I think. We'll do this and assign this to the color variable. So we're going to come in, we'll set this to be a user variable again. We'll make this the color that we've just created. And again, that should make this white if you'd changed anything. If we compile and apply this, we'll make sure we save it as well. Go back into our content browser here. And if we right click, create a new Niagara system. And again, we'll just rename this to ns_laser impact. So likewise, if you wanted to in here, we've got this new node. So you can come in and play around with the color here if you wanted to check what that will look like. But again, we now have everything ready to go. So we can make sure all of this is saved. We'll close these again. And I'm going to create a new blueprint now in the blueprints folder. This is going to be really simple. All I'm going to do is create a new actor. I'll name this one BP_laser. And in here, I'm just going to create a sphere mesh component. So just so that we have something to see the center point. Quite important here, because I'm not going to bother too much about changing the collision settings and everything when we're looking at our line trace component. I'm just going to set the collision preset here to none or no collision. And then in the event graph, we're going to do some logic on our event tick. And first of all, we'll just need 2 Niagara systems. So I'll name the first one Niagara Laser. I'll copy this and I'll call this one Niagara Laser Impact. I'm also just going to grab the sphere, drag this onto the default scene route as we won't be needing that. And we can now start doing some of our logic to get the laser and the impact playing. So first of all, in the Niagara Laser, I'm just going to set this to be the laser system we've just created. And then the impact, I'm going to set that to be the impact system, again, that we've just created. So the first thing we want to do is we're going to set the color of our different systems. So we can control drag in the laser and the laser impact. From either of these, I'm going to pull from this and we're going to use the set color parameter. So this is a particle system specific function. You can see that it takes 2 things, the parameter color that we want to pass in and the name of the parameter. So this is the first thing you need to be aware of, is this is just going to relate to the variable that we've exposed in the system. If you ever forget what that is, then just go back into your emitter, go to the user exposed, and it's this one here, the color. So we're going to make sure that including case sensitivity, we type this the same way. And then we're going to set the color that we want this to be. So I'll just make this a kind of reddish orange laser. Then I'm going to copy and paste this just so I don't need to set everything up again. I've named the other one the same thing. So we'll just plug this back in to this time the laser impact, and then plug the execution pins together, and that will set those up. Another way we could have done this is just plug both into one. Because I'm going to set these to be the same color, this would work the same way. If you wanted the impact point to have a slightly different color, a different shade or something, then you can obviously do it the way I just showed you a moment ago and have both with their own unique set color parameter. So the next thing is I'm just going to paste in a little bit of information here. Hopefully this is fairly standard and kind of familiar to most of you. We're going to be using a line trace by channel, so not something too specific to the topic, but this is basically just getting us to trace forward. Very, very standard stuff. You can see this in all of the templates for like the first person shooter to trace forward from the gun. We're basically getting the start point as our current location, so the location of this actor. We're then adding to that the forward vector, so the way that we're facing, multiplied by the distance forward in which we want to trace. So I'm just going to promote this to a float variable. We'll create that. And for now, I'm going to set this to be a hard set value. I'm actually going to come in and show you a little bit of a trick after we have the basics of this working, but I'll set this to a value of 1000 for now. I don't know if you noticed in the demonstration, but I had it that when you begin play, the laser kind of slowly extends outwards, which is an effect I quite like. And I'll show you the logic to get that working when we have the basics going. Now, if you wanted to see what this will look like, I've got the drill debug on. So basically what we're doing is from, I'll remove the old example, pull in the laser example, and you can see that's just tracing forward based on the direction we're looking here. We can see that the start of this is working. The laser is indeed the color that we've selected on the begin play, that orange color that I selected here. So that's the first parameter working. It is, of course, facing the wrong direction, but that is perfectly fine for now. Then the next thing we want to do, this is going to be a little bit more specific to our particle system, so we will be looking at this rather than copying and pasting in some of this basic code. Do note here that I have a reroute node, as we will be using the information from the direction that will, or the end point as it is here. We will be using this in a moment. So the first thing we want to do is control where the laser is going. So I'm going to control drag in again the Niagara laser, and this time remember we had that other parameter, we had our laser end vector point. So we're going to set a vector parameter this time. So again, just another particle system function here, the set vector parameter, expecting two things similar to the color. It's expecting the name, which was laser end. So remember, if you've called yours anything different, check the emitter, and it should be this one here. We're going to plug this in. And at the moment this won't work. There's going to be some trickery that we add to this in a moment, because remember that we won't always be hitting something, which means the end may need to change how far away this is, depending on whether we have or haven't hit something. So in fact, we can do that now. If we pull from here and we'll say select, so we'll do a utility select, and we'll pass in whether or not we are blocking something. And what we want to use, if we are blocking something, so if we have hit a solid surface, then from this line trace, then we're going to use the hit location of that point as the endpoint for our variable. If not, what I'm going to do is I'm actually going to promote this to a variable rather than having lines everywhere. So I'll promote this to a variable. I'll name this one trace end, and we'll just plug this in here. Completely optional, but I could see that otherwise we're going to have wires kind of extending everywhere. It makes everything a little bit harder to read, and obviously blueprints can be kind of messy enough as they are, so we'll tidy this up where we can. We could even add this to a reroute node, plug that in here, and try and make this a little bit better somehow. Maybe that's made it worse, I don't know. Let's leave that. So the next thing is we're going to control drag in the trace end, and if that's false, so if we haven't hit something physical, we don't have a specific point to stop the laser, and obviously this would stop it going through a surface. It'd look a little bit weird if you could see a laser coming out the other side, in which case we're going to just draw this laser until the end point of this line trace. So again, this now should be working. If we come in and simulate, we can see that starting from the start point and going all the way to the trace end where that red line was a little bit earlier when we looked at the debug. So we can see this in action. If we change the distance now, we'll change this to 100, so we'll have a really short laser. Then we only get it going 100 units. The next thing is if we set this back up to be obviously much bigger, We also want to check our logic that when we overlap something, this will be accounted for. So I'm just going to drag a cube in, move this slightly ahead, and we can see that should hopefully stop. So yeah, the laser is only going as far as the cube, but you can see the line trace is going much further through, so that 10,000 units. And if we set this to movable and move the cube, then that's going to go all the way. So this is how we're going to get the laser to be stopped if it hits something. And the next thing is our Niagara laser impact effect. So at the moment, you may not be aware, but this is kind of in the middle of the sphere. It is playing, but of course we can't see it because we don't have this set as to be in a certain location. So what I'm going to do is, again, based on whether we're hitting something or not. So in fact, this is another one which otherwise we could be pulling out to loads of places. So I'll promote this to another variable. I'll just call this one B hit, nice and simple. Plug this in here. That means already we can tidy this up. We can have a node under here instead of some overlapping lines there. And what we can do is we can, first of all, set the visibility of this. So we'll do a set visibility function. And this is going to be based on whether or not we are hitting something. So we'll set the new visibility. If that's true, then this will be visible. If it's false, then it will be set not to render. So just a very simple toggle there. We don't really need to do any checks. We'll just let that kind of manage itself. Because when we start moving this around, when it's not hidden in the middle of this sphere, we obviously don't want this to be visible at the end of the line if there's nothing hitting the end of that laser. It just wouldn't really make visual sense. And what we can do, we can either throw in a branch, or because we're toggling the visibility anyway, we can either throw in a branch to only set the location if we're hitting something. But I think because we're already hiding this if we're not hitting something, we can very simply just set this again, and we'll set the world location. And we'll set this to be the hit location. And again, that just irritates me a bit. So we're going to promote this one to variable. We'll call this one hit location. And we'll plug this in just here, just so everything is going to be kept nice and readable as we go through. And in fact, that actually helps us here. That means we can plug this in. So again, that means we can completely remove this node, kind of put it out of the way somewhere. And it makes things a lot more readable here in one go. So if we've hit something, if that's true, we're going to choose the hit location. If it's false, we're going to choose the trace location. Then we can use our hit location, plug that in here. We don't need to sweep or anything. We just want this to visually be moved around. And again, now we can test this. So it should be that we see this, there we go, appearing at the end of our cube. And then if we move that, forget to turn that to movable, we can see it disappears as soon as that cube's out of the way, because we don't want that to be drawn at the end of our line over there. Okay, so just double check, because that was a little bit hard to see something so far away in the distance, but I think that was definitely being hidden when we weren't hitting something, so we can definitely see it there. And again, still not movable, but it's fine. Okay, so yeah, it's not drawing there. As soon as the cube's back in the way, there we go. And that's pretty much how we get our kind of dynamic use of our particle system. So we're just setting a few different things here. We're setting the vector parameters, the color parameters, and a lot of things in Niagara can be exposed as parameters in this way. And then the small trick I wanted to show you, this is kind of an extra. You might want to keep this on screen for a bit. I'm just going to copy some code in again. This is the logic I was taking. It's probably not as tidy as I could make it. It was just a very quick test as I went through. But this was the code that I was using to get that extending line as soon as the laser begins. So what I was doing is, we're not going to set the distance to be a specific value. We're going to start this at 0. We'll let this be added to a certain value. So if the distance is less than a set amount, which I'm just going to say is 5,000, then we're going to multiply this by a fairly big number as we go through and set the distance until this reaches its limit. Now, the other thing we want to do is we're going to update this as we go through. So in fact, I think we will set a branch node here. So I'm going to use a branch. And of course, we want to make sure this is either reset or updated as we go through. This is going to be based on whether or not the blocking hit has been set. So we have our B hit. I'm going to plug this in here. And the distance then will be the return of our hit location. That will be minus another vector, which is going to be our actor location. And then we're just going to turn this into we'll turn this whole vector into a length. So we're going to use the vector length, which will return a float. And we'll plug that in as the final value for our distance. So again, if something is blocking us, we're only going to do this on if we are being blocked, then this is going to override this. It's going to reset it so that the distance is only going to be from the start point to wherever we're hitting. So we now have a kind of more dynamic laser. And if we just watch this in action, the main thing to watch out for here is I'm going to set that to movable, move this out of the way. And you should see that rather than starting off at the full length, this is going to slowly kind of extend itself. And I kind of like the look of that. You can obviously tweak how fast that happens with the value just here. If you wanted it to go out really slowly or much more kind of quickly than this. But I think that's a pretty useful value. And then the other thing that we can get is you can have that extend all the way out, drop this down. It's going to go straight back to where the hit point is. And then when you remove that, it's going to go back out again. So I kind of like that effect. I just wanted to quickly show it's not really fully on topic. So just a quick copy and paste of that if you wanted to see the logic that I had for the demonstration. And then of course, setting the distance to be the vector length if we have hit something. Okay, so slightly longer one this week, but hopefully this has been a useful insight into using Niagara, working with things, like I said, in a kind of more dynamic way. People have definitely been asking a lot about the use of these parameters through the Niagara systems. Like I mentioned, this is a very simple look at exposing these variables to the editor, to your blueprint, and working with them that way. If you wanted to see more on this, if you had any specifics that you're looking for, do let me know down below. Your comments are read and I do respond to them. I do try and make content like this based on the requests as soon as I get the chance. But hopefully for those of you who have been asking for at least the basics of getting these parameterized variables working, this is going to be a little bit of an insight to get you going. Of course, if you wanted to support the channel and the work that I do in these tutorials, then you can have a look at the Patreon page. The more support I can get over there, the more I can focus on the channel. I am completely freelance at the moment, so I need to balance what I make for the channel with my freelance work. And obviously the less I have to leverage on the freelance projects, the more time I get weekly to create content like this, which is a little bit more of a deeper dive into some of these topics. If the subscription model isn't really your thing, but you wanted to learn a little bit more about Unreal, if you're just getting started, do consider checking out the course that I've released. It's a complete beginner's intro to UE4. It's very adaptable to Unreal Engine 5 as well. People have already said they've gone through using that and is already making complete sense and working with the new engine. Again, links for that are in the description below. It's a very comprehensive course starting from an empty project all the way to a complete game, including a widget system, menu, and various different kind of cool tricks that we can use, some editor things like spline systems to create simple level generators. And again, things like that help me support the channel with the use of those more in-depth, longer courses. Or of course, you could always just leave a like, subscribe to the channel, and make sure you hit that notification bell so that you'll be updated with any of the future content that I release to the channel as soon as it goes live. Just wanted to say a big thank you to all of those people already supporting me over on Patreon. As I mentioned, it's your continued support that allows me to make these multiple releases per week and some slightly longer videos. As ever, thanks for watching, and I will see you all next time.